Hello, friends and dear viewers. I welcome you all for this current episode wherein we are going to discuss about the soil and the process of formation of soil. And in the course of discussion, we need to discuss about certain important and most interesting things like the weathering, the erosion, transportation, of course, the deposition. So far, we have dealt with so many issues, particularly related to the ecosystem, of course, the atmosphere, etc. Friends, I think I need to uh, discuss in detail. I need to discuss in detail, particularly with regard to the soil and the way it is formed. And in this context, I request everybody to enrich or enhance your fundamental knowledge regarding the discipline geography so that you can understand well and you feel enthusiastic and, of course, satisfied. Right. So, weathering. Basically, I think before giving the definition weathering, friends, I need to explain a little bit. A little bit. The Earth's crust is constantly undergoing geological changes that may be caused by the internal forces as well as the external forces. These forces, of course, the internal forces create new relief features. Relief features in sense, dear friends, what are all the things which you find on the surface of the earth? They're all collectively called as relief features. Orogenesis build new mountain ranges. Uplift or depression of particular areas is caused by folding or faulting. I repeat once again, friends. Orogenesis build new mountain ranges. Uplift or depression of particular areas is caused by folding or faulting, and volcanic disturbances also modify the landscape. Meanwhile, external forces are working vigorously to wear away the surface, and the interaction of these constructive and destructive forces gives rise to the great diversity of present day landforms. The process of wearing away the earth causes a general lowering and leveling out of the surface. And this process of wearing away the earth, causing a general lowering and leveling out of the surface, is popularly known as denudation. is called as denudation. With internal forces, friends, you understand, I think, which is a constructive process. That means it forms a number of relief features. On the other hand, external forces, they used to wear away the surface, and which is a destructive one. So the interaction between the internal forces and external forces give way for the present day landforms with great diversity. So denudation is the thing, or which is the pioneer for the various various processes. And so denudation is carried out in four phases. Number one is weathering. It is weathering. Friends, I just give a small definition, or I'll try to put it in a simple terms so that you can understand what weathering literally means. The weakening, rotting, breaking up, and the disintegration or decomposition of a rock in situ by natural agent at or near the surface of the earth is called weathering. It's called weathering. Of course, it is a static process and does not involve any movement. It does not involve any movement. So, friends, now the work of weathering in breaking up the rocks is of two kinds, namely the chemical weathering and the physical or mechanical weathering. But the processes involved in each are closely interrelated. They are closely interrelated. Right, friends? Let us quickly jump onto the chemical weathering. Chemical weathering is the basic process by which denudation proceeds. By which denudation proceeds. It is the extremely slow and gradual decomposition of rocks that is due to exposure to air and water. So, air and water, they contain chemical elements which, though they may be in small quantities, they are sufficient to set up the chemical reactions in the surface layers of exposed rocks. And such reactions, they may weaken or entirely dissolve certain constituents of the rock. Hope you understand, friends. Here what's happening, the air as well as the water, they are the things which contain some chemical elements, even though they are in small quantities, but that is sufficient to set up the chemical reactions in the surface layers. Okay, that is sufficient in the surface layers of exposed rocks, and these reactions, they may weaken or entirely dissolve certain constants of the rock, and in that way loosening the other crystals and weakening the whole surface. For example, friends, if you see in Malaysia, where the surface of granite, which has been exposed to the weather, is found to be pitted and rough. That is, pitted and rough. And this is because the granite is made of three main minerals. That is made up of three main minerals. One is the quartz, the feldspar, and mica. And mica. The feldspar is more quickly weathered than the quartz, and thus the feldspar crystals are worn away. The quartz crystals are eventually loosened and in this way and form a coarse sandy residue. The quartz crystals, they form coarse sandy residue. When the surface of a rock is weathered, some of the material which is loosened is removed by erosive agents. You note this word, dear friends, erosive agents. The general erosive agents are the wind or running water. Thus exposing a fresh surface to weathering. But much of the weathered material or regolith, of course, regolith is nothing but the remains of the rock. It is nothing but the remains of the rock. It is called as regolith. And that may stay in position forming the basis of soil. Friends, I think you understand. Regolith, it may stay in position forming the basis of soil. So, regolith is the ultimate source for, for the formation of soil. Right. Regolith is it's simply the mineral remains of decomposed rocks. But soil contains organic materials such as the roots of plants, the fallen leaves, small animals such as the worms, the bacteria, and so on and so forth. Of course, it is the organic content of soil which makes it fertile and allows crops to be grown. Hope you got the point, friends. The regolith, when combined with decomposed rocks, mineral elements, the roots of plants, the fallen leaves, small animals like worms, bacteria, etc., it gives scope for the fertility, which ultimately helps us to allow crops to be grown. Right? Now, when a soil cover exists, chemical weathering of the underlying rocks does not cease. I think you understand. Even then, there is a soil cover, but the chemical weathering of the underlying rocks, it continues. It does not cease. Okay, and on the contrary, on the contrary, it is usually enhanced, and this is because the soil absorbs rainwater and keeps the underlying rocks in contact with this moisture. So that is the reason. Even then the surface, the soil is covered, but the underlying rocks, they are continuously undergoing the process of weathering, and that is because of the absorption process of rainwater. The soil, it absorbs rainwater, so that the underlying rocks, they are in contact with this moisture and keep on undergoing the process of weathering, right? The rainwater absorbs organic acids from the soil and thus becomes a stronger weathering agent than pure rainwater acting on bare rock. The most important and interesting thing, my dear friends, the rainwater absorbs organic acids from the soil and thus becomes a stronger weathering agent than pure rainwater acting on bare rock. So it implies that the rocks which are underneath the soil, they are supposed to undergo the chemical weathering to a greater extent when compared to the rocks found on the surface of the earth. This is mainly due to the soil water mixing with the organic acids that are present in the soil. That is the main reason why the rocks underground, I mean, underneath the soil, they take up the weathering process to a greater extent. Right. There are three major chemical weathering processes. There are three major chemical weathering processes. The first one, solution. Here, many minerals are dissolved by water, and especially when, as with the rainwater, it contains enough carbon dioxide to make it a weak acid. Solution is the most potent weathering process in limestone regions because the rainwater attacks and dissolves the calcium carbonate of which the rock is chiefly formed. So limestone regions we are talking about. And now the dissolved calcium carbonate is carried away by the water. Of course, it joins and cracks in the rocks are equally widened, and whole systems of caves and passages are worn out. Okay, they're all worn out. Limestone, however, is by no means the only rock to suffer from solution. All rocks are subjected to solution to some extent. And of course, though the process is much slower than when compared to this limestone. And the rate at which solution takes place is affected not only by the mineral composition of the rock, but also by its structure. By its structure. Sedimentary rocks often have pore spaces between the grains in which air and water can lodge and thus attack the rock. The density of joints or cracks is also crucial to the speed of weathering. And this fact is very clearly seen in Malaysia, that is in the weathering of granite, and in tropical countries where the heavy rainfall and warm climate, they both promote rapid chemical reactions. Weathering often proceeds very rapidly. This produces the very deep regoliths or soil overlying the solid rocks. Soils overlying the solid rocks. Often these regoliths contain core stones, and these are pieces of solid rock which have resisted weathering while all the surrounding rock has been weathered. They are more resistant because they have fewer joints or cracks to harbor moisture and are thus more slowly weathered by solution processes. Friends, I'll provide a beautiful diagrammatic representation to understand the process of weathering, particularly this chemical process. And rates of weathering are also affected by climate, whether it is warm, wet climates. They generally promote rapid chemical weathering, and dry climates inhibit chemical weathering. Hope you got my point, friends. Generally, chemical weathering, it is implied that it doesn't operate in dry climates. It takes place only when there are some there prevails some wet conditions. So dry climates, however, provide good conditions for physical or mechanical weathering. One of the most interesting thing, dear friends, right? The other one is oxidation. The other one is the oxidation, dear friends. Oxidation is the reaction of oxygen in air or water. We all know very well, friends. Basically, oxygen is present in the air or in the atmosphere. Of course, in the water also, it is present in the dissolved nature. It is present in dissolved form. Oxidation is the reaction of oxygen in air or water with the minerals in the rock. For example, most rocks contain a certain amount of iron, which, when it comes in contact with air, is changed to iron oxide. The familiar brownish crust or rust, okay, that is iron oxide. And this iron oxide, it crumbles easily and is far more easily eroded than the original iron. Okay, iron oxide is eroded easily than the original iron. It is thus removed, loosening the overall structure of the rocks and weakening them. The other one, dear friends, that is the decomposition by organic acids. Friends, we are all now we are dealing with the things which falls under the chemical weathering, and now it's turn for the decomposition by organic acids within the soil, which covers most rocks are bacteria which thrive on decaying plant or animal material. These bacteria produce acids which, when dissolved in water, help to speed up the weathering of the underlying rocks. Within the soil, which covers most rocks, there are bacteria which depend upon the decaying plant or animal matter. And these bacteria, they produce acids which, when dissolved in water, help to speed up the weathering of the underlying rocks. And in some cases, the microorganisms and plants like mosses or lichens can live on bare rock, right? As long as the surface is damp, these absorb they absorb chemical elements from the rocks as food and also produce organic acids. They are thus agents of both chemical and mechanical weathering. Friends, that is to do with chemical weathering, wherein we have dealt with the solution, oxidation, and decomposition. These are the three ways or the three forms by which the chemical weathering takes place, and where the rocks underneath the soil surface are being degraded by these three ways, and so that ultimately leading to the formation of soil. Hope, my dear friends, I have given deep insights to the topic and many more interesting things also, like regoliths, which are the fundamentals or basic sources for the soil, etc. And I entered a little bit deep into the geomorphology part, my dear friends, in order to justify the topic. And it's time for us to move on to the another form of weathering, that is the physical or mechanical weathering. That is physical or mechanical weathering. Friends, I think it's time for us to wind up this session, and hope let's take a fresh session, or let us take a special episode to deal with the physical or mechanical weathering, so that you may be comfortable in understanding the things clearly. Hope you all enjoyed this session, dear friends. Thank you. Thank you, one and all.